Oh. Divide by 2, divide by 2, divide by 2, divide by 2. Oh, did I write it down yesterday? Oh, you could have divided this one by 2. Yesterday, we chose this one because it looked easier. Divide by 2, divide by 2, divide by, and divide by 2. But you could have done either one. Remember, row echelon form, there isn't just one set one. There are many different ones. So yeah, Jason, I was just being lazy because I was like, divide by 2, divide by 2, divide by 2. What did I just do for this one? Did you guys see it? Divide by 5, divide by 5, divide by 5. Because row echelon form says I want a 1x, a 1y, and a 1z. Oh, wait, we still need to do that, yeah? Huh. No, go ahead, Priscilla, what's up, kid? I usually use it for that. I could have used this one, kind of like how Jason brought up. I didn't actually end up using that one for the first equation because I was like, you guys aren't going to like dividing and getting tons of fractions. If we divide by 2, it's nicer until there. Same thing here. I could have divided this by -10, but in my mind, that was kind of harder than just dividing by 5. But either one would have been legal. Yeah. And they all should, as long as your math is right, they all should lead to the same place, like the same final answer. I'm rewriting him because do you guys see that I'm going to do 2 times him? So then that'd be 10y plus 10z equals 10. Wait, no, times 2 times 2 times 2, that's 4, right? Find my mistakes if I made them. Find my mistakes if I made them. Now technically, if you didn't necessarily do exactly what we did yesterday, you could have your first equation being 1x plus 1/2 y plus 3/2 z equals 1/2. And you would be right. That would be a row echelon form. That would be fine. And you could have chosen this one or this one to divide by the leading coefficient to get the second one. But still, all of us should have ended at z equals 0. Unless someone found a mistake. How many of you guys are or got to z equals 0? Cool. Question? Yes. Which is why yesterday, when I was kind of making this example, an illustration of our system, I said eliminate the x bars using R1, R2, somehow by making terms, the x terms match, and then R2, R3. Because we have to go ahead and get 2 equations with only 2 unknowns to then go ahead and eliminate the y's to get just to the z's, and then boom, 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 we're done. Does that kind of make sense? Oh, sorry, we didn't yet. I was on the last example. Okay, but what did Precalc say? Yeah, it's time to finish, right? So when we finish, or when it's time to finish, we need to go ahead and say, well, hold on, z is easy. We have him. He's 0. We need to take z, go ahead and plug in to find y. So y plus 0 equals 2/5. Well, y is equal to 2/5. That's not bad. Then we're going to go ahead and plug back in for x. So we plug in for y equals 2/5 and z equals 0. Now, I don't know about you guys. It's starting to get a little rough in my head. So I'm going to probably do a little like, okay, x plus 3 times 2/5 plus 4 times 0 equals 3/2. 0, well, that's nice. That whole thing is just a 0. I have 6/5 and 3/2. Uh-oh. Okay. Yeah, let's go ahead and do x is equal to 3/2 minus 6/5. Oh, you guys are just finishing it off for me? Because I would go ahead and make him into tenths, right? So times 5/5 would be 15 tenths minus, and then make him into tenths by doing 2, so 12 tenths. I think I have 3 tenths. Double check me, though. 3/2, take away 3 times 2/5 is 6/5. 3/2 minus 6/5. 15 tenths minus 12 tenths is 3 tenths. Now, book. Like if this was, this isn't even, so I guess you guys don't necessarily go check in. It's very possible that they could do decimals. They could do 0.3, and then 2/5 is 4/10, so they could do 0.4. They could do 0, but either way, same thing. Questions on the process? Questions on how we finished it? Questions on what we did? Are we okay? Let's go grade. Let's see how homework went then. Section 7.3a. Ooh, it doesn't look right. Where's 7.3a? There it is. And I have 7. Oh, I'm in the wrong section. 7.3a. There we go. Okay. The nice thing is for number 8, wasn't it just a plugging and checking, right? And to be a solution, it has to work not just in one, but in all. Yeah. Which is why you see in letter A, one of them doesn't work, so fine, we're done. No. But in letter B, to get a yes, all 3 of them had to be true. And letter C, one of them, at least one of them didn't work, so no. And letter D, at least one of them didn't work, so no. Now be careful. If they were being really tricky, could one of C or D or A, could it have worked in the first and not in the second? It's possible. So be careful. Be careful. If they're being really nice, they're going to give you one that doesn't work in any of them. But if they're being really mean, they could have one that works in the first 2 and fails in the third. It would not be a solution. It has to work in all 3. Number 12. Oh, is that one already nice? Look at that. Look at that little stair step. Boop, boop, boop. They didn't even get a leading coefficient of 1, but you can still back substitute. They didn't force you to get proper row echelon form. They just said solve. So hopefully you guys got 2, -3, and -2. Number 22. Yes, I know you could have done substitution. Yes, I know you could have done elimination, but we were practicing row echelon form with an easy one before going to a harder one. So it's up to you. You could have done substitution. I get it. You could have done elimination. I get it. On the test, you probably could choose unless it was a long answer, and I probably wouldn't give you a little baby one for row echelon, because there are easier ways to solve it, but you were just practicing. So if you did do row echelon, you could have stolen him as your first equation. You could have done elimination to get a y and a number, then back substituting, boom, there you go. But I know there were lots of ways of getting this answer, -3, 2. But now in 42, whew, this one's row echelon. Let me try to, as you guys are checking, something weird happened in this one, right about here. But let's just go through the steps real quick. Now, they're writing all of this explanation as to what they're doing. I would have done it all nice and color-coded. We're eliminating x, we're eliminating x, we're eliminating y. Where's z? No, literally, in this one, where was z? We'll get there. But eliminating x, eliminating x. They stole this guy to be their first. They were going to divide by 2 later. They're being lazy right now. It's okay. It's not proper row echelon form, but that's all right. It'll work. They did elimination with these 2, probably multiplying this guy by -2 all the way across, adding together. That's how they got this guy. You could have very easily divided everyone by -2 to make it pretty. They got both of their, like Tyler, you were asking, they did it twice. They eliminated x twice. Those are those 2 equations. They then did elimination with those 2 equations and got what? True. A true statement that means infinitely many solutions. But what did I say in our notes yesterday? I wanted you guys to do, yeah, Matthew's trying to say it. He's saying z. Right here. In either infinitely many case, either one where you get a true, oh, here's true. Sorry, he's hiding. A true statement. Let z equal a. Why? Because there's no z. There's no z. I'm used to z equals 1, z equals 2. I can use you. I don't have anything. So what did they let z equal? No, they didn't write it super nice and pretty. I would have, but they didn't. I would have actually written this in row echelon form. Do you guys see how they did go ahead and divide everybody by 2? And divide everybody by -2? And the little stair step they were supposed to? But I would have technically, if I were you, I would have put a little z equals a right here and been like, hey, yay, there's my row echelon. Dun, dun, dun. And then once you have all three, now what do? Plug in. Y minus 4a is equal to negative 1. So then you add the 4a to the other side and say you're ugly, but you're right. Well, he's not ugly, but I'm guessing that's what most of you guys would think. Like, okay. Don't reject him just because he's ugly. Z gets plugged in. Y gets solved for. As soon as we have Y and Z, what do we always do? I know they're not numbers, but what do we always do?
Plug them in.
Go back and plug them in. Oh, hey, look, there's no Y spot. Whew, that would have been a mess. All we have to do is plug in Z, right? So x plus 1/2 a, plugging in, Z is a, is equal to 5/2. Sweet. Subtract to the other side. Dun, 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 dun. Also a messy expression, but it's completely and utterly true. Yeah. All right. So what do you do when you get a true statement? What do you do when Z disappears? You let Z equal A, and then you do your back substitution as always, not afraid of the expression you're getting. Because the long story short, there are infinitely many solutions, but they are still bound by certain conditions, like the picture that we saw yesterday. There are infinitely many solutions, and however, whichever case it is, we're not even going to stress about what case it is. Whichever case it is, whether it's infinitely many but it's only this straight line, or whether it's infinitely many but only on this plane. It's infinitely many but only, which is why we need these little baby equations in terms of A to say, yeah, everybody that works here. And in our case, for this specific example, infinitely many, everybody but only these ones that are bound by this condition. With that, kiddos, that was the end of homework. Do you guys have any questions on evens and or odds? My book is open and ready to go. Matthew.
What if you try getting rid of the x's first, like we did for the homework spiral problem we did?
Yeah, that's what we would have done to get this first equation. See, they got rid of the x's to get this guy, and they got rid of the x's to get this guy. Now, they wrote it weird. They didn't do our nice, pretty setup as far as writing it off to the side. They actually wrote these two kind of like in, and then they kept on writing the system, check it. They wrote it over and over and over and over and over and just kept on like adjusting it every time. I like having off to the far side the row echelon and doing all of my work building up to it. So our strategies are a little bit different, but the exact same procedure is still happening of eliminating x's, getting y's and z's, eliminating x's, getting y's and z's, eliminating y's and getting z's. They were doing that, but they were doing that in the midst of eliminating x's, getting y's and z's, eliminating x's, getting y's and z's. They were doing lots of mental math, basically is what they were doing. Then eliminating y's and getting, oh no, the z went away. And then they said, oh, we have to divide everybody by 2 and divide everybody by 2. Well, there we go. And then I would have written that little z equals a down here and gone back. So I would have written it a little bit differently, but basically, Matthew, the math is happening. Our procedure is happening. It's just they're not showing clearly where or how. Does that kind of make sense? Yeah. So this I would have had, and this I would have had over here. I would have had it looking like this. And I would have done all of this work on the side. Any other questions? Whether figuring out what CalcChat is doing or the solution or how to tackle a problem, etc. Yeah, Priscilla. Which one? Okay. Salma, anything else? Okay. Let's start with 17 because he's right over here. This one is actually, number 17 isn't telling us to do the whole problem. It's literally just saying do this one operation and talk about it. So we have to figure out what on earth it's asking us to do. It's saying add equation 1 to equation 2. Wait a minute. If I was telling you to add equation 1 to equation 2, we'd be doing our R1 and our R2 step of eliminating that. It'd be wrong, but in our system, we'd be adding them, subtracting them, doing something to them in order to accomplish this. So let's see if it accomplished that. So if we add the first 2 equations, which is what they said to do, oh yeah, we're eliminating x's. So when you do add down, you get 1. There are a few different things you could say. You could say, what did this accomplish? Well, I did eliminate x's. You could also say that we got 1 in terms of only y's and z's. You could say something to the effect of, for row echelon form, we got the second equation. There are lots of different things it accomplished, actually. We did eliminate x's in 1. We do have an equation with y's and z's to carry on to the next step, and we have 1 we can put into row echelon form. All of those answers are good. But I'm guessing the back of the book or CalCat probably would have focused in on, hey, you got rid of x's. Good job. But then Priscilla, I'm sorry, 37. He was a full Mama Bahama, like, let's tackle the entire thing, right? Okay. If you don't mind, I'm going to go pretty quick. That way you can check your steps along the way. So I'm going to eliminate x twice. I would have kept that first one just as he is and multiplied the second one by a negative 3x, which would have needed to distribute all the way across. Those of you guys that got it to work out, just double check my steps in my math, okay? So multiplying by a negative 3, multiplying by a negative 3, a negative 3, and a negative 3. Okay. Then I would have gotten negative 9y plus 9z equals negative 9. Then over here I would have taken my next 2 equations. That bottom guy, I would have kept the same and multiplied the middle guy by a negative 5. So negative 5 times x, negative 5 times 2y, negative 5 times a negative 5. So easy to make mistakes in like multiplying by negatives and making sure it goes all the way across. Got to be careful on that. That's a negative, right? Yeah, negative 18. Huh. In my mind, I'm thinking of dividing because I'm like, these all have a 9 and those all have an 18, and man. Now you could just take them down to the next step of eliminating y, which I'm actually going to do up here for sake of space. But if I was thinking of my row echelon form and building it, I would probably be lazy and steal this guy. X plus 2y minus z equals 5, because he already has a 1 next to the x. But you could technically use any of them. But then I would use at least one of these for the second equation. So I'm going to divide him by negative 9 all the way across. For sake of my row echelon form, I'm going to get 1y minus z is equal to 1. But when I come up here to solve, even if you hadn't done that yet, if you just left it as it is, in order to do elimination, we're going to want this first one to match. So I think I'd multiply him by 2. And not just 2, I need it to be opposite signs. So I'm going to multiply it by a negative 2. And I'll get what should be looking a little awkwardly weird, because when you multiply by a negative 2, so what is this? It's a z equals a example. There are infinitely many solutions. These are intersecting not just in one point, but either in a line. And this is one of those examples where I say, okay, z is equal to a, whatever. Take that a, plug it in. Y minus a equals 1, so I can go ahead and add a to the other side to get y. Then let's plug that a right there. Gets a little nasty. We'd have to plug in our new y value of 1 plus a. I'm going to come up here. So x plus 2 times 1 plus a minus, solving for x, having gotten the other two. And pretty quickly, I think you guys can double check my math. We end up with x equals 3 minus a. How's it looking, guys? Matthew? And see that they match? You might not necessarily need to go do that step to be like, oh, let's equal a. But either way, we should both arrive at the same basic conclusion. if you divided both sides, like divided by -9, divided by -18, what you have to look at is, are they exactly the same, variables and numbers, or are they exactly the same variables, different numbers? Because when you go to do an elimination, if they're exactly the same on both sides, you're going to get 0 equals 0, or the same expression equals the same, like 5 equals 5 or 10 equals 10. But if the sides, if these sides were the exact same, the signs and everything, but they equal different numbers, you're like, it's impossible. They can't equal different things if they're the exact same. That would be a false statement if you went and did elimination. But to keep it safe, Matthew, you technically could be like, I think something funny is going on, and then go do elimination with it, and you'll see. True or false? Oh, I thought you meant no solution versus infinitely many. I apologize. No solution is going to be what I just said as far as the left side's matching but the numbers not matching. Versus one solution, they're a little bit different. And when you solve, you're going to get an actual z equals a number. But the nice thing is, if you follow our system, you don't really have to be looking per se. You kind of just need to be going through the steps and then taking this final step is where you're going to see it. Before you get to, when you're trying to get to z equals a number. If z equals an actual value, that's one solution every single time. Remember, the only time we have to go for infinitely many or none, none will be a number equals a number, your z is gone. False. Infinitely many, let z equals a is a true statement. So those are both our special cases. Went to do this, z didn't equal a number. If z equals a number, there's one solution, one only, going to have 1 point and be done. Okay. Covered Priscilla's, covered Salma's. Anything else you guys want to talk about for homework? Evens or odds? 7, 3, A. All right, let's go see what B's talking about then. One more homework tomorrow. Yeah, I don't think it's as long. Has anybody peeked at Google Classroom yet? Like 7 problems? Okay. And the reason why it's 7 problems is, long story short, do you guys see why I would be a little afraid if I had given you guys number 44 for homework? And why I wanted to split up homework and be like, let's take one more day. But you've gotten so much work done already, and you've already worked with row echelon form, and you did a homework spiral problem at the beginning of class. Most of you are like, I kind of get the idea. Maybe not perfectly, but I have a way to tackle any 3-variable, 3-equation system. Now, what's the lemma of number 44? 3 variables, 2 equations. Didn't Algebra 1 tell you that was impossible?
Yeah.
Didn't Algebra 2 tell you that was impossible? We need as many equations as we have variables. We are little robots. Well, in some ways they're right. To get to a unique solution, unique meaning specific, meaning single solution, like what Matthew just brought up, a single point. I think we had known. I think Joe's thinking of the pictures. Remember, guys, as soon as you have x and y, plane, not just a line. X and y, y equals mx plus b, you have a line. X and y and z, you have a whole plane. 2 planes intersect each other. 3 planes can intersect in a point, and we saw that picture yesterday. I'll be right back. 3 planes can intersect in 1 point. If they're all at different angles to each other, none of them are shared. 3 planes can intersect in 1 point and 1 point alone, but 3 planes can also intersect in a line, and 3 planes, well, I guess, could technically all be the exact same plane. Kind of awkward and weird, but okay. But what if we only had 2 planes? That's what this is about. Number 44 says you only have 2. Now, it's not perfect. because technically planes have no depth, and no depth means you can't feel it, and I can feel these pieces of paper. So these aren't perfect planes, but it's about the closest and the thinnest that we can make it, right? Can these intersect in only one point? Yes. Wait, planes go on forever. Well, if I say yes, what's the problem? My representation of a plane stops, true? But would the actual plane stop? It would keep going. And if it kept going, what would it hit in? Not a point, but a line, because it would actually be going through. Pretend they're going through. So any two planes can't possibly meet in a point. They can only meet in a line. Now maybe they meet everywhere. Maybe. But since they go on forever, they can only meet in a line. Now, it starts to kind of mess with our brains a little bit, because a lot of us aren't used to going from like the first dimension to the second dimension to the third dimension and how they interact and intersect. There's a cool book someone wrote once called Flatland, A Romance of Many Dimensions. And it's basically walking through someone in the 0th dimension. How do you do that? Something in the first dimension, second dimension, third dimension, like how someone stuck in a certain dimension could visualize a higher dimension. Some of you guys might have watched recently A Wrinkle in Time, although you might have thought it was cheesy. But some of that discussion was talking about going out to different dimensions, even though there was a lot of funny stuff also. But it's interesting to think about if there are multiple dimensions, if you've ever pondered that. Go research string theory. Your mind will get thrown for a huge old loop. But for our purposes, let's not stress about all the things I just said. Instead, let's think practically. If we were to try to solve this, we are missing our pause. Can we still do R1 and R2? Yeah. Huh, okay. Let's do what we can. Isn't that a life lesson? You look at something, you're like, I don't know how to do that. Do what you can do. We can do R1, R2. All right, let's see what happens. R1, R2. Anybody want to multiply R1 by -2? Me too. Let's go. Eliminating the x's. -4x minus 6y minus 6z equals -14. You guys double checking my math facts? They match up with yours? You guys all adding down? Do you agree with my 12y plus 9z equals 30? Yes. Sweet. Let's go find that. Oh. How much of row echelon do we have? Yeah, Joe's saying we only have 1 and 2. We can't do 2 and 3, but couldn't we still have a first equation in our row echelon, guys? X plus, divide everything by 2. 3 halves y plus 3 halves z equals 7 halves. We have our first equation. Couldn't we have our second equation? Sweet. Divide everything by 12. 1y plus 9 over 12. That reduces 3 over 4? 3 over 4. That's true, Joe, but I'm going to remember, get my proper row echelon form, which means 1x, 1y. Equals, 30 over 12. That reduces as well to be 5 halves. What's the one thing I wasn't able to get? So guess what I'm going to do? I just said it can't be 1 point, but it still can be an answer. Oh, z equals a. Really? Yeah. It's just like if you got 0 equals 0. The whole bottom row cancels out. And you're like, great, I'm stuck without. Hey, we're stuck without on this one too. It's the exact same solution. Exact same procedure. There isn't just one solution. It's impossible for two planes to hit in only 1 point. So therefore, okay, fine, bless you. Let's go looking for the line. And the line says let z equal a. And so at this point, I know, I'm going to do some quick plugging in. But if I go put a in for z, y plus 3/4 a equals 5 halves. If I subtract 5 halves minus 3/4 a, there's my y. And I know it's messy, but I have to now go ahead and get back to this one too. Not just plugging in z is a, but also plugging in y is now 5 halves minus 3/4 a. But it's okay. Nobody ever got an A in math by doing the best mental math. Take your time. Show your work. What you got to do. X plus 3 halves times 5 halves minus 3/4 a plus 3 halves a equals 7. Halves. Ugh. It's not pretty. Just take your time. I'm going to zoom in. But if you guys notice, even though it's messy, we really just have x needing to be solved for. Making sure I plugged in right. Did I plug in right? I think so. I have A's and I have non-A's, and I have an x that needs to get a loan. I have A's and I have non-A's. Let's go ahead and figure out what's going on. So I'm going to distribute that. 15/4 minus 9/8 plus 3/2. What do your brains see? I'm just curious. Do you want to get rid of all your fractions, or would you just start tackling the A's with the A's and the numbers with the numbers and get x alone? Common denominator? Okay. Common denominator. Well, the first one would be multiply both sides by 8. If you multiply both sides by 8, which would be the common denominator, right? If you multiply both sides by 8, you're basically saying if I got the common denominator and multiply both sides, then it would all go away. That's a cool way of using the common denominator trick. So you could use 8x plus, what's 8 over 4? 2, and 2 times 15 is 30. 8 over 8 is 1. 8 over 2 is 4. 4 times 3a is 12a. What do I do to one side? 8 over 2 is 4, and 4 times 7 is 28. There we go. So if you don't mind, we can get rid of all of our fractions at once by multiplying both sides by the common denominator. I see a 3a. I'm going to take away my 30 real quick, which will be a -2. I have my 8x plus, and hopefully you guys pretty quickly would subtract the 3a and divide by an 8. Ugh, it's gross. That's right. Matthew. 2x plus 3y plus 3z is 7. Okay, do we need to be scared of 2 equations, 3 unknowns? No, but we need to realize it's not going to be one numeric answer because we don't have our z equals number. But we can put a z equals a. Is that okay? Technically, sorry, I didn't even say the vocab, did I? This is called a non-square system. How come? Because we have 3 equations, but, sorry, no, we have 3 unknowns, but only 2 equations. A square system is 3 unknowns, 3 equations, 4 unknowns, 4 equations, 5 unknowns, 5 equations. Yeah.
So, say this was like a bigger amount of like unknowns. Could you only have a non-square system with one less equation and unknown? Like if it was 4 unknowns, could you only do that with 3 equations?
Well, think of it this way. The same way we let z equals a, let's say we had another variable that was also missing, or the inability to find another variable, we wouldn't be able to stick or have the solution in terms of only 1. W equals e, and then we'd have equations in terms of 2. If we were missing 2 like a before.
Okay.
Does that make sense?
Yeah.
So kind of like our solutions would just get messier and messier with more and more unknowns, the more that are missing. Does that make sense?
So it would kind of just like end up being rearranging.
Kind of. Which would be a little bit simpler because you'd have 1 less or 2 less or 3 less unknowns, but yeah, it would still be harder. Priscilla?
Would there be a question like this if I go over?
It could be. I think I would probably rather have this be like a multiple choice, to be honest. There are some applications you guys are going to see, and so this is basically homework help. What I didn't show you yesterday, and why we have an extra day on this section, and why homework was split into 2, is because, first of all, I wanted you guys to see the weird, like, wait a minute, we don't have 3 equations, which is what we just dealt with, but z equals a. But also, what are some applications of systems of equations? And here's 2 of them, just 2 that get brought into the homework. One has to do with position, a position function. If you take physics, you'll talk a lot about position and velocity and acceleration, motion, movement. But for our purposes, we're not going crazy into physics. It's basically being like, hey, systems can be used. Yeah, basically. But then there's also another application dealing with geometry. Okay. Here's the long story short. Let me just give you a couple hints as far as how to take a problem that says you need systems and figure out what the actual systems are. In number 48, if I was to go look there really quickly, and I could, that's not the right page. It gives us this big old paragraph of information for number 48. And what it says is, oh, go away, green box. Yes, you're focused. Thank you. Okay. Shoop. An object moving vertically is given heights at specific times. And actually, there are really cool computer programs that kind of do this. They can watch the motion, or you can record the motion of something, and you can actually figure out what height it's at after so much time has passed, etc., and it actually models it. Because if you throw a ball up and it lands, you're like, oh, sweet, that was a parabola. But what parabola? I don't know, it's a parabola. But if you could record it and put it into these different computer math physics programs, they could actually be like, oh, hey, tell us how high everything is. Sweet. After 2 seconds, it was here. After 3 seconds, it was here. After 4 seconds, it was here. That's what this is giving us. And each of these are a clue. Each of these say, hey, you know, when t, which is like our x, is 1, we have 132. And then it gave us 2 other ones with a t and with an s of t. And it gave us a secondary one. So we could do like t2 with an s of t2. You can take each of these and plug into this equation. And you can say, okay, I know that s is equal to 132 when 1/2 a. T is equal to 1. Well, 1 squared is 1, so just that's left. Plus, t is 1. Well, 1 plus v sub naught is v sub naught, and then s sub naught. If you have 3 different clues, how many equations are you going to get? 3. How many unknowns do you have? 3. Couldn't you, if you don't like the new letters, couldn't you just call A x and call v sub naught y and call s sub naught z? All you're doing is solving a 3 system of equations. That's one way. You make your own little system and then have to solve it, plugging in the points to your t's and s's. Now geometry, what? What's going on there? Oh, wait a minute, hold on, this is a triangle. So angles x plus y plus z have to add up to 180. Wait, these two are supplementary. So y plus 2x minus 7 equals 180, and these two are supplementary. 2x plus 7 plus z equals 180. That's 180, that's 180, that's 180. Hey, I have 3. Ew, it's all mixed up. Pause, it's all mixed up. Well, how do we make it not mixed up? Yeah, can't we like add 7 to the other side and be like, okay, that's going to be 187. And then we can go ahead and maybe move our x term in front of our y term. We can make it look prettier. Right? But all of that is just rearranging to be able to solve. And then we could, okay, we could move the 7 to the other side and we would have 173. But guys, at the end of the day, for both of these, we end up with a system of equations. Oh, too many pluses. And if you can rearrange them all, you're like, oh, sweet, let's go. Or after we keep on going and put in x's and y's and z's, let's go. Once again, you'd probably want to sort this one, move the numbers on this, the variables on the other. But both of these applications need systems of equations to be solved, but they need to be written first. They need to be written first. All right, bye, guys. See you later. Hold on.